Today, I'm going to talk about managing packages in Python. And before you can kind of get into actually managing and installing third-party packages like pandas, for example, you need to be able to, or it's better to at least just have a quick fundamental understanding of the basics of navigating via a terminal. So this is actually quite simple. But as you can see here, there is a file path. So it says PS, and that stands for PowerShell, because this is a PowerShell. That's Windows, the terminal that it uses. So ignore the PS. But then here, this is our file path. So if we were to go into the File Explorer and go to our C drive, then users, then Jack M, which is my account name, then documents, and then Python, you would see these files here, because this is where my current VS Code session exists. And another way that I can check where I am is if I type pwd, and that's pwd, so that stands for print working directory. Okay, so that's pwd. So that tells you exactly where you are on the file system. And you can see here it outputs just what I said there, which is the C users Jack M docs Python. So the next command is ls, which is list. And if we do, not list, if we do ls, you'll see that what this outputs is all of the files that exist within our current directory. So again, that's this directory here. And then in VS Code, we can also see the files up here because this is open in that directory. But you can see that we've got our customers and fruit.csv files, and they're up here as well. And then we've got the various Python files that I've been creating as I've been doing these lessons. So that's printing our current directory. So that's where we are. And also listing the items within the current directory. List files within current directory. Okay, there you go. So then this autocomplete is beating me to it. The next thing I was going to talk about is changing directory, which is CD. I'm going to turn the autocomplete off as well. Disable completions. There we go. Just so it doesn't distract. So CD, which is change directory. So we are in, documents Python. What if I wanted to go back or forward into a subdirectory? So for this, I'm going to create a new folder, and we can do it in the terminal, and I'll talk about that in a minute. But just for now, just because we're only focusing on changing directory, I'm going to make a new folder over here where I can do it graphically. So right-click, new folder, and I'm going to call this test_folder, and I'm going to put a file in there called myfile.txt. Okay. So if I was to ls and list the current directory, you can now see that we have up here test folder. And to distinguish it in my session, it's highlighting it blue, and it's not got an extension at the end here. So like that is what can distinguish it from files quite quickly. And depending on what operating system you're on or whatever this, or what terminal you're using, if you're using standard command prompt, for example, which is another terminal that exists within Windows, it might look slightly different. But this is a folder, I believe, and this is a believe, but I believe mode over here and D, I think this means that this is pointing out that it is a directory. So it's a directory is what we would call it. Remember how CD was change directory? Where we exist, that's our directory. So print working directory, list file within the current directory. Yeah, so that's what I think the D means, but might be wrong there. So to go in there, we would do CD, so that's change directory. And then we can type the name of the place we want to go. So if I take that away again, you'll see what happened is when I went T and then E, I could type this whole thing out, test_folder, but it's a little bit laborious, especially when you have lots of different directories you want to go through. But once you have enough unique characters that there's no other option for what it could be. So here, nothing else begins with a T. So T is actually enough. If I now hit tab, which is the key above the caps lock on the left-hand side, it will autocomplete. And here you'll see it fills out to test folder. So if I hit enter now, you'll see that our file path has changed. And we are now at Python/test folder. So if I do pwd for print working directory, we'll see that we're now in the test folder. And if I do ls to list what is here, we can see my file. So to go backwards, this is universal for for all terminals, Unix terminals. You do CD, and then you want to do 2 full stops or period keys. And if you do that, it will go up 1 directory. So I can do this as many times as I want, and you see how it's taking off an end to the thing there. So I'm going to go back into my Python directory, ls again, everything's there, so cd test folder, and we're in there, and I can go back again. So that's how we go forward and backwards. So I'll just do cd ... is to go up a directory, to go up a level, I'll put for now. When I do the autocomplete, you'll notice here that there's a full stop at the beginning of the file path. And what that means is that we are changing directory into a relative folder. And when I say a relative folder, I mean that this full stop basically tells it that everything after the full stop exists in our current context, in our current directory. Because if I was to do cd and then do like test_folder and just type it out like that without the full stop, what this is going to do is, instead of appending it to the end of the current file path, it's going to check if test folder exists all the way back here where we're actually trying to go into the C drive. So this will probably say cannot find it. So you see how it's saying C and then test folder. Nothing can be above C in the Windows like file system. So that's why it's putting C first, but it's saying test folder doesn't exist. And that's because we don't have the period or full stop key. So if you put that there, it then means within the current context. And that also should help you understand a little bit about why 2 full stops goes back. Because the first full stop is saying here, and then the second full stop just adds to that to basically say 1 layer above. So that's how that works. Okay, so that's pretty much it for navigating and getting around. We can see the directories that are here. We can see where we are. We can move into relative directories. Oh, and the last thing, just for bonus points, if you do ever want to make a directory, you can do mkdir, which is make directory, mkdir. So I could do make directory, and I'm going to do the relative file path again, so it makes it here. Because again, if I just did a / or a \, it would do it in the C drive. So I'm going to call this my second test folder. Very verbose name for us there. And then it's also doing the ls. It's showing that it was made. But if I do ls again here, you can see it alongside my file, and here it is. It's already up here actually in the Explorer up there. So I am going to move out of that directory, and then I'm going to just remove it up here, just so that's done. That is create a directory. Okay, so now that we know how to get around the terminal in a basic way, we're going to talk about pip. And pip is, and my autocomplete there is letting us peek ahead, but pip is a package manager that comes with Python. And when I say a package manager, what I'm referring to is libraries that are made by other people or companies that you want to use to help speed along your coding process. For example, we know that there is the random package, and it's not included in Python sessions by default. We have to import it, and we say import random. Well, there are lots of other packages that are made by other people that don't actually come included with Python, but we can still utilize them. And that's where pip comes in. So you can do pip, and then you can say install, and then you can pass it the libraries you want to install. So for example, you can see here I've recently used ones called requests and BS4. Those are used for fetching data from the internet and web scraping, which is one of my primary use cases when it comes to scripts. So before I do any of that though, I'm just going to type pip and hit enter. And without passing it any arguments, you can see it outputs a lot of, so this is where the command was, it outputs a lot of information about how it works. So it says there are several commands. So there's install, download, uninstall, freeze, yada yada. You probably should read this. I'll be honest, I think you'll only use, if you're like me, you'll only ever use maybe 2 or 3 of these regularly. And then you get some extra options as well. So going off this list, we can see that pip has a command called install, where you install packages. So if I type pip install and I hit enter again, And just ignore that. What's it doing here? It's saying you must give at least one requirement to install. So that's saying that I've not told it what package I want. So per its advice, I'm going to type pip help install. And what that's going to do is it's going to give me some more information about what install does specifically. So I'm scrolling all the way up. They give you lots of stuff to go on here. So that's where I type the command. It says usage, and it gives you some examples. So you can see it says pip install, and then it's got it says that's where you put your options, etc. This is a little bit long-winded because it's got these full file paths, but we'll skip that and we'll go down here. So install packages from, and these are the repositories from which it will fetch information. So PYPI is the primary like index of Python packages, where if somebody has built a Python package that they want other people or themselves to be able to utilize in different scripts or several like projects, that's where they will commit their code to, and that's where we can fetch it from. So generally everything, more often than not, will come from PYPI. And then you can see there's some other options here which we won't get into, but a really good habit to get into when using a CLI, so command line interface tool like pip, if you don't understand it, instead of just kind of googling and going crazy on there, you can always just talk to it in your command session and see what it tells you. So without further ado, let's install something. But before I do, without further ado, and then I stop myself, let's play with requests for a bit. So if I go import requests and then print requests, it's my sincere hope that it's going to give me an error, but I don't think it will. So if I run this, yeah, no, that didn't give me an error because I already have requests installed. Let's try a different one. Let's try pandas. There you go, squiggly lines. That's what I wanted to see. So pandas is it's a library that is very commonly used for interacting with complicated sets of data, like 2 or 3-dimensional arrays of data, like you might see in spreadsheets. So typically when we work with pandas, we would do import pandas as PD. And that's just something that's become standard when using the library, just to have like a shortened version of the library to use. But I'm not going to do that here just for the sake of this demo. So when I say import pandas, you can see I've got these squiggly lines, and that means that we have an error which is import pandas could not be resolved from source. And what that means is that Python is looking in all of my local directories where it has all of its packages stored, and it's saying, hey, I don't know this guy, I don't know who this is. And that's why if I run this, I'll get the error, hopefully matching that says module not found error, no module named pandas. Cool, so that's what we're going to rectify. So we're going to do pip install pandas. And if you hit enter and let it run, it says collecting, it's downloading it, it's downloading dependencies for it. And what that means is pandas itself will require other packages to work that other people have written. So you can see here it needs Python date util, numpy, 6, tz data, so that's time zone data. So it needs lots of other things to actually run, and it will handle those under the hood for you. And now that has been installed, it says successfully installed numpy, pandas, everything it wanted. But the key thing is it's installed pandas 2.2.3 for me. So I'm assuming that is the current most recent version. So what I'm going to do is I'm going to run this code again, but I'm going to use the terminal session here, and I'll explain why in a second. But if I do python learning.py, yeah, and it runs now. So you can see it's printing out, it says that this module pandas, this is where it's actually installed, and that's pretty much it because I'm not doing anything with it. But the key thing is that error has gone away. And the reason that I ran it in the terminal session was it still had this squiggly line here. So I wasn't sure if VS Code had identified that it was actually downloaded, because it might take a couple seconds to update. So I thought if I do it within this terminal session, at least I know that it's, it should be aware that it's been installed, because that was the last thing done. Cool. So we now have access to pandas. Some other good commands are pip list. And if I do pip list, it shows me everything I currently have installed. So you can see before, from before I've got Beautiful Soup 4 and BS4, and then where's requests and requests. So when I tried to use requests as my demo before, it didn't work because I already have it. And then we've also got pandas and everything else, which kind of looks a little bit like junk. These are all the dependencies which the packages I've elected to download requires in order to run. Now, this is the surface level of how we use pip, and it doesn't get too much more complicated, but what is difficult to manage at first is the packages that you have installed globally. And when I say globally, I mean that I can use these packages from anywhere within my computer now. So if I opened up a different folder, a new project, and I use this same version of Python from this same directory, all of them will have access to these packages, and you don't always want that. So I'm going to make a part 2 to this, which is going to be about how we section off our dependencies to make sure that whenever we are using Python, we are only using the packages that we specifically want for that project. And that is important because sometimes extra bloat that you're not aware is there can cause unexpected errors. So we want to try and make things as isolated as possible. If you are new to this, I wouldn't worry about that just now. Go ahead and just try it, play with it, install some packages. I think if you want to remove them, it's pip. I want to say remove, unknown command remove, so it's probably uninstall. Yeah, there you go. So pip uninstall. So I could undo my work here by doing pip uninstall pandas, and it's saying this is going to remove pandas. It's going to remove the dependencies for it as well. It's asking me for a yes or a no. I'm going to type Y for yes and hit enter, and boom, it's gone. So it's really easy to manage if you're only using 1 or 2 packages. But if you are going to start doing some more complicated stuff, you can check out part 2, which I will have uploaded at the same time, which will talk about isolating virtual environments.